Welcome to this lesson for Chemistry Paper 1. So today we're going to look at 3 or 4, if you have time, strategic practicals that you should revise for this paper, because I've been analyzing past papers of every exam board, and these are the papers that come up the most. Okay, so it's really worth it to spend some time to fine-tuning your exam skills for these specific topics. Okay, before that, we're going to look briefly at some basic exam skills, because it's very, very important that you're confident with the general skills, of chemistry, understanding your objective, the specification. Okay, so we're going to have a look at that. And then I will also remind you of, the possibility to join the core chemistry course that has the most important topics. It's called core chemistry because it really has the essential concepts of chemistry that you need for this paper, and who knows, maybe for your A levels as well. Okay, so if you haven't joined this course yet, this could be your chance to have your whole chemistry done with a recorded lesson, worksheets, a full workbook to try. So this is very important for you. So let's get started now with the exam skills. The most important thing you need to do before you start your chemistry revision is know your paper. Know exactly, and I want you 100% confident on knowing what comes up in paper 1, in paper 2, the type of questions that you will be assessed, okay? Because you're lucky that you do have enough time between papers so that you can focus on some very specific topics just after paper 1. Okay, so it's very important that you do that. Then, well, you can, like from the previous lesson, we talked already about the design, that first you build confidence, then you consolidate it, and then there are the most challenging questions. The objectives, of course, are very important. And I think the most important tip that I came up with is to understand this objective of apply knowledge and understanding. Yeah, which is these questions that you may feel unfamiliar with. So remember, this feeling of, oh, I don't know this example. I have no idea what this is. For example, look at this example. Calculate the mass of citric acid. What? What is citric acid? I've never heard of that before. Okay, so you don't get stuck on the defined details of the questions, but just on the overall topic, because this specific objective tests on these things, like the application of knowledge, yet to scientific ideas, techniques, procedures that you're not directly familiar with. Okay, that's why it's important that you get used to this. And I think by knowing this, as soon as you read a question that looks absolutely weird, you're like, oh, okay, I know that it's testing this objective. So the only thing to do is think about which topic is it referring to. And then you can more easily find the solution. Okay, in this case, for example, you need to calculate, like, what is it? Calculate the mass of citric acid. You analyze it, or you understand that you have to work out the moles and then the concentration. Application of 2 equations that are not that difficult. Okay, so it's very important that you get used to this. And I think by knowing this, you can really do the papers with a slightly different awareness. Okay, so very important then. Well, we will look today a bit on these third objective, which is analyzing informations and ideas, also to develop investigations and so on. Keywords, I hope you learned enough from the first lesson in biology. And then, well, we also, the type of questions are very common, multiple choice open questions. We know that the level type of answers. So instead of doing these mixed questions today, we'll go straight into the practicals, because like this, we get the chance to revise some very key topics. Before this, relative to this very important skill of knowing your paper, yeah, in order to then, prepare efficiently for each exam paper, the most important tool that you have for this is the specification. Okay, in this classroom, I have arranged the topics and the papers in a way that it's not like 200 pages to go through with some key required practicals. So make sure you look at this. Now, For IGCSE and Excel students, you have a very specific paper, a little bit different. So all the other students, you know, can take a break, take a stroll now, because I'll speak just 1 minute to IGCSE and Excel students. Again, 2 papers. The objective tests are going to be exactly the same, but here you also have organic chemistry mixed in, right? Now, paper 2, it has all the content, but in addition, you will have everything that is in bold in the specification, and I've put here as a list. All of this are like specific objectives and the skills of paper 2. Okay, that's why the specification can really help you revising things more, like to target more each paper. Okay, very important. Now, the second exam board, OCR. OCR students, you actually have a very similar paper to AQA. So I would highly suggest you to practice both exam boards together, because OCR has a really, really nice set of multiple choice questions at the beginning of every paper. So if you want to just try a few topics, yeah, to, you know, to just revise a little bit and mix up some topics instead of doing this long structured question, going to OCR past papers, paper 1, so you have this targeted multiple choice questions. It's such a good way to revise the key concept of chemistry, okay? And this is absolutely for everyone, okay? Again, the specification is extremely important. And the last one, it's AQA students. So once again, the same objectives that are tested. Everything is very, very similar. You have exactly the same topics in as OCR for paper 1. So make sure you practice both. Okay, and we're lucky because the practicals are similar for every exam board. Okay, and here you have the whole topic list, so make sure you look at this. If you don't feel comfortable with the specification, that is such a big document, you can just look at this summary list on your classroom. Okay, now before I move on, you might say, oh wow, but why are we mixing all of the specifications? Well, trust me that it's the best type of exam practice that you can do, because like this you learn to get unfamiliar with the content and the structures. Because if you think about the objective tests are the same, demonstrate knowledge, apply knowledge, and interpret. And if you can interpret slightly different structured questions of different exam boards, then you can answer to any. So if they change a little bit this paper that comes up, or they change a bit the type of questions, well, you're prepared because you have a much broader experience. So please really try this, yeah, to see just how to get a bit uncomfortable, because at this point of the year, maybe you've done so many past papers that you don't know where to get more notes. Okay, so it's such an important skill, so I really invite you to try. And now let's dive in some practicals. Required practical number 1 to revise is making salts. Okay, so this is, I've seen it in so many past papers, like 6 marker questions of describe this, so it's worth to practice it. Now, I want to revise just very briefly the key concepts, because well, there is a lot more chemistry in this topic that you think, because we are going to be looking at the neutralization reactions. You have to remember the neutralization reactions is when we have an acid and a base reacting together to form a salt. You can have even so many questions about this. You could be asked to write down a neutralization reaction, or to work out the formula of the salt, or even write a definition of what the salt is, or write a definition of acid and base. So notice that it's just this little concept. There is so much chemistry. Now remember, acids, pH lower than 7, base, pH higher than 7. Acid, it's a proton acceptor. Proton donor, so it's everything that has like H, for example, HCl. And I would highly suggest you to remember some of the key formula. For example, acids, the one that I would suggest you to remember is sorry, I'm going to try this one. So the one that I would suggest you to remember is, for example, hydrochloric acid, sulfuric acid. So as long as you have some formula to remember. So acid, everything with H, H2SO4, okay? And the base, yeah, it's either an oxide, for example, sodium oxide. We could have also a carbonate, magnesium carbonate, or potassium like an hydroxide. Okay, so there are some key ones to know. The one that doesn't have oxygen, therefore doesn't form water in the neutralization reaction, it's ammonia. But it's still a neutralization reaction because a salt is formed. And remember that. So I'm going to write an example here. HCl plus NH3. Can you guess what are the products? Remembering that an acid, it's a proton donor. And a base is a proton acceptor. And by proton, we mean the H+. Now, revision of bonding, hydrogen is in group 1. What does that mean? 1 electron in the outer shell. But if it loses that 1 electron, it's only left with 1 proton in the nucleus. So it's called proton. 3, 2, 1, write down the formula of this salt, because it is the only neutralization reaction. We will see that doesn't have water as a neutralization product, but only the salt, which is NH4Cl. In fact, ammonia is one of these ions that I would highly suggest you to remember. So if you're not sure about polyatomic ions, make a big list of these common ions, because you must be very confident in writing down the formula of these. Okay? So that's just a little crash course on the neutralization reactions. Then we are looking also at separating technique, filtration, evaporation, and crystallization, but we will see it in action in the diagrams below. I would invite you also to look at the recap questions to really just test these very specific concepts relative to this topic. The practical. Now, let's just look at the diagram first, and then I will show you how you can write it in, as you can see, 6 bullet points, very down to the point, because if you had to write a 6-mark question, then I would suggest you to do it this way. So the first step would be, if you have an acid and a base, now here also we can be quite flexible on what it is, you warm up in this case, the acid, and then you add the base. Now, very important, whenever you're discussing a solution, for example, warm up the dilute acid, you can explain so much more about it. So always mention about the properties of the solution, so the volume and the concentration. Okay, so in fact, notice first step, measure out a volume of dilute sulfuric acid or just any acid using a measuring cylinder. Extremely important whenever you're describing an action in the practical, mention the glassware that you're using, the instrument, so measuring cylinder. Okay, then warm the dilute sulfuric acid in a beaker. Look again, the beaker with a Bunsen burner, because you really want to visualize everything perfectly of this experiment. And if you don't mention a beaker, where do you put the acid? Okay, it may be obvious for you, but you risk to miss marks like this. Then add copper oxide 1 spatula at the time. Okay, here we're adding insoluble base. In fact, notice that we could have insoluble metal, base, carbonate. This depends on the question that you're asked. Very, very important is until is in excess. Okay. Questions of analysis would be, how do you know that is in excess? What do you do after if it's in excess? Why do you add that in excess? Okay, so you would add this in excess, and here I'm looking at now step number 2. You would add it in excess because you want to make sure that all of the acid reacts, and it's a lot more difficult to control the exact amount of acid if it's a solution. Because if it's insoluble base, you can just filter it out. So the second step will be filtering the mixture, and we're looking here. Using, of course, funnel and filter paper. Once again, look how nicely we're describing the instruments used. And then we have the solution containing just the salt. And the last step would be, of course, to obtain the pure salt is warm on the water bath until the crystals form, like evaporate. So as long as you mention and describe nicely, this crystallization. Okay, you don't have to over explain it, but say the solution becomes more concentrated, but just saying evaporating basing, heat it up, and then allow to dry in air. Okay. And then there are a lot of nice questions that can be asked here, and we're going to look at some examples to just go straight into some exam practice, because you will see that it is actually a very broad topic. Okay, so I'll select now a question to do together. First question to start, that is not directly the practical, but everything related to reactivity of metals as well as the bases and acids, so neutralization reaction. So let's get practice this one. If you're watching the recording, you must pause the video now and play only when you've tried the answer. And if you're with me now, get writing. And when we play again, we will be doing the solution. Let's correct this question. Now, true observation. It's very important that you look carefully at the physical state, okay? Very important. So even if you don't have the reaction down, but you have to write the reaction, make sure you analyze and write the physical state, okay? Very, very important. Now, where are the marks here? Two observations, we will see. We can describe it in many different ways, but the essential thing will be bubbles. Why? Because there is a gas formed, so bubbles. Fizzing or effervescence, okay? Then, what other change do we see? Well, calcium was a solid, and it's not. There is no solid anymore. So, calcium is a white solid, and this white solid will disappear. Sorry, let's just write actually not this, but let's just say that calcium or the solid disappears. Okay, so solid disappeared. Okay, or calcium solid moves up and down because there is this effervescence. Okay, so those are true observations that we can clearly state from the question. There are some others that are not as straightforward. For example, there is going to be an increase in temperature. So the solution would get warm. Why? Well, because it's an exothermic reaction. Neutralization, they're exothermic reactions. Okay, so that's one. Then calcium hydroxide, it's actually it's not really white, but it's like a white substantial, like it's milky. Okay, but not straightforward. So those I think are the three to suggest. Okay, pH, that so pH that could be formed. Yeah, we will have a hydroxide. So the pH is going to be above 7. Okay, a possible value for pH though, and explain. So there are 2 marks involved here. Yeah, would be you could say any value between like 11 and 14, as long as it's quite high. And then why? Because we have calcium hydroxide, which is an alkaline solution. Okay, so pH, and then mentioning what is responsible for this pH. Okay, part B, we have the salts. So as I said, because we're looking at, well, part of we're looking specifically at reactions of calcium here, so we're revising a little bit the like reactivity of metals and actually acid and base as well. But this could also all be part of one of these questions of making salts. Okay, so solid X now. When calcium carbonate react, even if you don't know it, and this is the typical example of question that you're like, wait, but I don't really know, you can work it out. Yeah, and notice carbon dioxide has been released, so one must be solid X, calcium oxide, because if you remove CO2 from CO3, what do you get? Just oxygen. Is that straightforward? Okay, now maybe you identify, and actually just to name also some reactions, because we're here to revise for the exams. This one is called thermal decomposition, because we're breaking up a compound with heat. Okay, thermal decomposition. Then calcium hydroxide, dilute HCl. What does it form? Well, I hope you realize it's a neutralization reaction because hydroxide and hydrochloric acid, so we would have calcium chloride. Remember to check always the periodic table to see if you're writing the formula correct. Always use the periodic table even if you feel super confident with it, because you can really make it visual, you know, to write down the formula of the ionic compound. Okay, and then calcium hydroxide with carbon dioxide, and you guys know this reaction, calcium carbonate. But you know what this is? And you know what this is? This is lime water. And lime water, it's used as a test for carbon dioxide, which turned a milky solution. So this is the milky solution. Okay. Because it's actually a milky solution because it's a solid, so it forms a suspension. So this is actually the observation for test for carbon dioxide. I know this was particularly difficult because we combine so much knowledge from so many different topics into this flowchart, but I hope it was helpful to revise. And now we're going to go into the next question. Second question for this practical, again, relative to salts, but it's not that simple. We're mixing up different topics, revising different topics. And here, very important, this concept of state symbols, as well as naming salts. Okay, so take your time, pause, and play when you're ready. It takes skills to do these questions because there is really a lot of background knowledge that you should have. And if you don't, if there are any of these words, for example, that you don't feel comfortable with, well, this is the time to revise because you still have time before your paper 1 to do that. Okay, so never neglect the foundations of chemistry, the basics. Okay, in fact, the things here are very important. Yeah. Soluble, insoluble, what does that mean? Insoluble means that doesn't dissolve in water. Soluble means that dissolves in water. Okay, now this, of course, affects, it has an impact on the physical state. For example, if you have to write down a, like an equation, okay? So anyway, I'll go straight into the solutions. The name of the insoluble salt, we have silver nitrate and sodium chloride, meaning that the silver goes with the chloride, yeah, and the nitrate goes with the sodium. Okay, remember we mix up cation and anion, so we will have silver chloride. Chemical equations, so silver nitrate, and here that's what I'm saying, that is extremely important that you remember the polyatomic ions. Okay, for example, that nitrate plus sodium chloride gives silver chloride plus sodium nitrate. Now, to be honest, I think it was easier to do the equation before you named the salt, but you can choose it, okay? Then the question always gives you some hints. For example, imagine that you have this question and you don't remember the formula of nitrates. How, like, panic? No, just look at the rest of the question. You always have some hints there, right? In fact, look, you have the formula here. Seems obvious, but now here you're quite, chill with me. But imagine in the exam, you might have this thing. So make sure you look at the whole question whenever you feel a little bit stuck, because you can really, you can get some hints there. For example, the formula of nitrate, the formula of sulfate is right here. Okay, now we have insoluble salt, meaning this is solid. Okay, the others are all aqueous because sodium, salt are always aqueous, sulfates are aqueous, and nitrates are aqueous. There we go. Now, other parts. Identify the acid and the alkali prepared sodium nitrate. Nitrate, we will have nitric acid, HNO3, and alkali, it's with sodium, so it would be sodium hydroxide. Remember, it's alkali. Alkali is a soluble base. If it was just a base, you could have used sodium carbonate, sodium oxide. But alkali normally is the soluble base. I would suggest you to remember the hydroxide. So I hope you got it right. Now, a little bit of practice on the titration. It's the second part because we do need to learn to read these. So please take just a minute to practice the reading of the burette. Sometimes also how they print out the paper or they do the questions doesn't help the interpretation, right? So you need to look carefully. Look, this looks like, doesn't really look like a really nice burette. Anyway, you know the generals of how to read the burette, because notice that they go in the opposite direction, kind of the length. So it's very important that you practice this a little bit. So the burette, after adding the alkali, so we are here, and the value would be 22.30. Then for the before, we're here. Notice that is right to the point here. In fact, we can never be more certain that the 0.5 here. So if it's in the middle, it would be 0.5. We can't say like the other, like any smaller, because it doesn't have such a high resolution. Yeah. So this would be 3.6, and after, and the total volume was just the difference, but 70. Let's keep the significant figures consistent. Okay, so this is the solution. Now we need this because, of course, there is a second part of the question, which I am going to show you right now. And we get started. And this is, of course, a past paper question. And in fact, it has quite extensive in terms of the steps that it has. Okay, let's go with this one and play when you're ready. So concordant result, where here you have all of the information you need. In fact, the only ones correct would be these two, meaning that to find the average would be 22.5, 22.6 over 2, giving us 22.55 as the average volume. Okay, now you may ask, but Sarah, we've just done the salt practical. Like, what does it have to do with all of this question? We're getting there. Yeah, because you know that exam questions, they tend to link so many things together. Look at this next one. 5 marks, pause, take 4 to 5 minutes to do this. Here we're linking with this question the practical of salt, or at least the part of it. Okay, so notice how if you have the knowledge, the basic knowledge, then you can apply to even more difficult questions. So which step to obtain dry crystals of sodium nitrate? Well, we would have the filtration. And then here you can explain, of course, what you're filtering. And then we would have the, leave the crystals to dry. And I would suggest you to suggest either like on a filter paper, because you're drying in air, so filter paper, or on a towel, or in an oven. Okay, so this is how you would dry a crystal. Okay, for example, you could say leave in for example, filter off or pour off the water, and then leave to evaporate the rest of the water for dryness. That would be perfect. Yeah, or you could say leave in warm place, yeah, I think those are the key parts. Then calculation, yeah, you must have these skills, because it can be in any question of any paper. Okay, and if you have been with me, if you've followed me for a while, you know that I always say start with moles ratio moles, because this really gets you started in any calculation whenever you have like grams, masses, MR. Okay, moles ratio moles. So first thing, we have sodium nitrate, and we wanted to find the sodium nitrite and oxygen. Calculate the mass. So moles, what can you find the moles of? You can find the moles of the sodium nitrate. Okay, remember here, let's not skip steps. Always make sure you write all the labels. So 1.7 over 85. This will give you the moles. What's the ratio? It's 1 to 1, because as you can see, we have 2 to 2, meaning that these will also be equal to the moles of sodium nitrite. And so how do you find the mass of sodium nitrite? It would be the moles that you found times by the MR, which you also needed to find. Okay, so here you do need the periodic table. Yeah, and I want you to write these labels, because a very common mistake is that you see this MR and therefore you use that same MR. So if you write the labels, then you make sure that you use also the correct MR. So notice that is a really common distraction mistake, because this question is so, well, for some of you might be very simple. Okay, And this should give you 1.38 grams. And I hope you got it as fast as I did. Go. So I hope you got experience in a quite different type of questions. Please access the rest of the paper to try the more open question of like describe the whole experiment and develop write the investigation. So you have a couple of open questions to try here with the mark scheme at the end, because I think it's relatively simpler compared to the questions that we've seen. And now, next practical. If I had to revise another practical for chemistry, it would be this one. It would be electrolysis, because apart that, you're going to have a question on it. Yes or yes. So revisiting the key concept is extremely important. So first of all, some of the definitions: electrolysis, electrolyte, anode, cathode. Okay, extremely important that you know each of it, because you can have so many questions that come up for like 1 mark or they suggest, That's why please go through these recap questions. Now, electrolysis, remember, we're breaking down a substance containing ions by electricity. What is a substance that contains ions? It's an ionic compound. Metal plus non-metal. Have the periodic table with you, because you will need to work out charges of ions, okay? Electrolyte, it's a liquid containing free-moving ions, which is broken down by electricity in the process of electrolysis. Now, a liquid that contains free-moving ions. Ionic compound conduct electricity only when molten and in solution. When molten and solution, very important. And the reason why they conduct electricity is because they have free moving ions. Do not get confused with the localized electrons, okay? Because ionic, we have the ions, so the electrons are with the ions, and then they're free to move around. Then anode and cathode. So anode, positive electrode, cathode, the negative electrode. I know it's counterintuitive. There is one way in which I like to remember it, because I do need a bit of logic and a bit of visual, otherwise I don't remember things. For me, the way to remember it and not get confused, and you may feel like, oh yeah, I know this, but remember, during the exam, the anxiety levels are different. You must have different ways to get to a solution, and sometimes this can really get you out of the black hole, Anode attracts anions. Cathode attracts cations. Anions are the negative ions. You see here? Negative. Cation, do you see it as I see it? They're the positive ions. Therefore, you know that cathode is the negative electrode, anion is the positive electrode. Okay? It can get confusing in the exam. Trust me on that. Okay. So this is my tip for visualizing it. Please go through the recap questions in your own time after this lesson. Okay? And one very important thing that I want to do together to revisit this is to write the formula of ionic compounds, because this is really one of the most basic and important skills that you need to have. Okay, so we're gonna try just two. Let's try iron chloride and iron sulfate. Now, forms at anode, forms at cathode, okay? Remember, one important thing, they're solutions. Solutions means they're aqueous, okay? And there are two rules in electrolysis that you must remember. At the anode, the rule is, and actually I'm going to write it down here. At the anode, the rule is oxygen forms unless an halogen is present. What's the halogen? Group 7 element. Cathode, the least reactive cation forms. How do we know which one is the most and the least reactive? Reactivity series. Okay? Take a minute to try this formula and what forms anode and cathode, and then in your own time, you can complete the rest of the table. Here is the solution. So remember, to work out the charges, use the drop and cross method. If you're not sure, please go into the core chemistry course and check the videos, or in the YouTube channel, I have some videos on it, okay? Forms at the anode, we follow the rule, and at the cathode, the least reactive ion. Now, remember the reactivity series. If you don't, there are other videos where I explain how to remember the reactivity series with some mnemonics, okay? So if you didn't get this, please do practice in ionic formula and then a little bit more on the reactivity series, and then you can come back into this topic, okay? Remember, the basics of chemistry are extremely important to do this. Now, let's look at the process of electrolysis, just so that you're reminded of the diagram. We see it in two different ways, and very often you would have to draw out the apparatus. Very important that notice they look a bit different, because here we have like a test tube where we can collect the gas. So it's a different layout, while here it's in the solution, but the gas would just escape the solution, always with the beaker. The important things to label: the power supply, we always must have that, anode and cathode, and the solution or electrolyte. Notice that whichever of these labels you use, it's fine as long as you use them. Okay, and so to investigate something, you will probably have to draw out this apparatus, so make sure you include all of the labels. So the observations are always what you're going to have to write down in a question. So here you have another chance to practice, but I will go straight into exam questions, and this, I hope you will be able to practice it on your own, and practice also the observation for some specific ions, okay? So to not do like that very directly a question on the practical itself, but another on electrolysis, which I think is super important to have clear. But notice that you can apply the basics concept of like the apparatus and the product to this type of questions. So please go ahead and play once you're ready. So here we're looking at electrolysis, and specifically the extraction of aluminium, okay? But the concept of electrolysis is always the same, but there is a little thing that I want you really to revise in this example. So one thing, first of all, electrons, the electrons are made of carbon, both of them, okay? Because it's a lot cheaper than the metal, and they are inert and conduct electricity. Which forms of carbon? It's graphite. Remember, graphite is able to conduct electricity. Why? Because for every, remember, it has this like hexagon kind of shape, and then we have different layers of this hexagon type of shape, and there are weak intermolecular forces between the layers. But the important thing is that each carbon in graphite is bonded with 3 other carbons, so we have 1 delocalized electron, so graphite is able to conduct electricity, okay? So very important things here. Again, we're looking at electrolysis, okay, of ionic compounds. What you remember about physical properties of ionic compounds? They have a very high melting point. Why? Because the bonds require a lot of energy to be broken, because they're very strong, okay? In fact, the reason of the very high energy, it would be the high melting point, okay? And here, it's ignored the reference to the strength of the bond, because it doesn't ask you that. But if you had to explain the reason of the high melting point, it would be referring to the strength of the bond. How is kept low? We use, instead of a pure substance, a mixture, because mixture have lower melting points than pure substances, and normally they melt over a range because it's like an impure substance, while pure means it's made only of one type of element or compound. And the mixture is mixed with cryolite. Cryolite, sorry to make that. Cryolite, it lowers the melting point, okay? So the operant time is kept low because it uses a mixture, so we can say aluminium oxide. dioxide is mixed with cryolite. Let's go with the part C, D, and E of this question. It's a 6 mark in total. And I really want you to take a moment to analyze the half equations because you do have to be able to write them down. So make sure you understand what's going on. Oil rig, to remember that reduction is gain of electrons, and the 2 marks are reduction, and aluminium has gained 3 electrons. Okay, we see it from the half equation. Then carbon dioxide is formed. We said about the electrode being graphite. In fact, it would be that the oxygen that it's formed, where at the positive electrode, at the anode. Okay, what it does, it reacts with carbon. And that's how we get carbon dioxide. Okay, good. The next question was about 2 properties of aluminium that makes it suitable for its use. Not refers to cost, which is often what we refer to, but it's about properties of metallic compounds. Malleable and low density are the ones that I think we should state. Okay, and also here use a bit your logic on like uses of substances. Okay. Anyway, well done for this question. Now, I will invite you to try the rest of the questions. For example, here we have a very nice method that it's used, and then you can interpret a little bit of like data that is collected, because very often, I mean, we just described the setup of the apparatus and then we did the extraction of metal. So we didn't look exactly at the investigation, but in this type of investigation, you could have, for example, that like you change, like you measure the mass of copper, or like the mass change of an electrode, and then there will be some interpretation, okay, for example, writing a conclusion. So I think this would be a very nice question for you to try, okay? And then also some a bit more unusual apparatus to interpret. I have selected this question specifically for you to practice some different style of them, okay? And now we're gonna look at the last practical for today. Temperature changes. The 2 key concepts to remember here are exothermic and endothermic. Exothermic, remember, energy exit, exo, energy leaves the reaction. Okay, so transfers to the surrounding. Endothermic, endo, in, takes in energy from the surrounding. Okay, recap questions, please give it a go after this lesson. The practical. This is what we use. This is what we use, okay? Literally is well, it's either a styrofoam cups or it's called a calorimeter. But if we had to write the practical in 6 marks, it would be like this. Measure out your reactant. Again, if you're measuring, mention with what you're measuring. So measuring cylinder, solid would be a scale, okay? Place a polystyrene cup in a beaker, prepare a lid with a thermometer, add a reactant, record the temperature. Add reactant to the cup, place the lid, stir gently, record the highest temperature reached. With this method, there are a lot of key things because the most common question for this topic is to discuss why the value that you got is not like the same as the book, or where could error be, or how to improve the experiment. And of course, because we're measuring temperature, we're measuring the energy transfer, which means that you always need to make sure that you don't lose any of this thermal energy. That's why styrofoam, cup, thermometer, stirrer, it's very important. Okay. And then, anyway, we're measuring the temperature changes to identify if a reaction is endothermic or exothermic, or with investigating a variable. So relatively simple, but let's try straight away a practical question, just one for this practical. And we can have several types. Notice that some are like relative to slightly different apparatus, but notice that you would be given enough information to interpret. And some others would be just interpreting some data. Okay, so let's select a question. I think actually this is good. Ooh, you know what? We haven't done a 6 marker, so I think it is the time finishing off the lesson with planning an investigation for 6 marks. Now, planning an investigation, there are some common steps for every practical, so you can really just focus on the structure of your answer. So let's get started. Let's mark this question. So I want to show you the mark scheme because it's a type of level question, of course, which means that you need well, of course, it's a valid outcome, but notice key steps identified and logically sequenced. Okay, so let's see which are the key steps and make sure you tick them in your paper, in your book, if you got them. Measure the acid, put it in a container, add the base, measure the temperature, repeat with different masses. Now, notice that to get every mark and to get really the 6 marks, you have to mention all of the instrument that you use. So you notice how what I said earlier, that whenever you mention about measuring something, state what you use. This will really improve your marks. So measure hydrochloric acid with a measuring cylinder, and then of course polystyrene cup, and then we would measure the initial temperature. At a known mass, again, measured with a balance, stir. Very important. Remember that in the diagram that we saw earlier, there was this stirrer because we want to measure the temperature of the homogeneous mixture. And then measure the highest temperature reached. Here what you could do is control, for example, how long, like the time, or you can just wait until like you measure the highest temperature and then it drops. Okay, here it's quite you can explain it as you prefer. Repeat, of course, is very important, but also repeat the whole investigation, because we know that we always want to repeat and find the average. Okay, then control variables, you must mention them always. So control variables of all the factors that would affect the investigation. Same starting temperature. Whenever you're using a solution, always think about the volume and the concentration of that solution, if it's the variable that you're changing or the one that should stay the same. In fact, here, volume of hydrochloric acid and concentration would stay the same each time, because what you're changing is the mass of sodium carbonate. Now, what affects also the mass, like this investigation, could be the size of the carbonate that you use. So if you use different masses, make sure you use like the same powder. Yeah, you don't use like a big chunk and then a powder, because this would change the surface area to volume ratio and it would affect, even though it's not written over here, but you know about this surface area to volume ratio. Okay, so I hope you got most of the marks, or otherwise I hope now you know how to get 6 marks in an investigation. The next step is for you to go through everything else, because it's not just about designing the investigation, but also interpreting the results, like it would happen in this question, but this will be up to you. Okay, so please make sure you check the rest of these papers. And if you would like to check the other practicals, I have also prepared a similar document for titration, okay, which is of course very important. Okay, there is also in your classroom another paper of must try questions with the topics that are a must, yeah, to revise for this paper 1, because they will come up, or they are foundation concepts that you must know. If there is any topic that you feel not confident with, and hopefully you made a note of them as we went through today, go to my YouTube channel and check videos specifically for that topic, which I probably have, or the core chemistry course. Everyone, thank you for joining. If you have any questions, yeah, comment this video or please text me.